Hello everyone, welcome back. Today we are going to discuss Vxlan IRB, Integrated Routing and Bracing. Vxlan IRB allows the VTAP to perform routing and bracing. Bracing will be performed when we forward the traffic within same subnet or same VNI. Routing will be performed when we forward the traffic between different subnet or different VNI. In this particular session, we are going to focus on Vxlan routing. Let's start with Vxlan gateway. So Vxlan gateway acts as a bridge between Vxlan segment and other network types, such as VLAN or Ethernet networks. Vxlan gateway is responsible for routing, bridging, Vxlan tunneling. There are two types of Vxlan gateway, layer 2 Vxlan gateway and layer 3 Vxlan gateway. Layer 2 Vxlan gateway is also known as Vxlan bridge. Layer 2 Vxlan gateway is a device that is responsible for encapsulating the Ethernet frame into Vxlan frame and decapsulating the Vxlan frame into Ethernet frame. Means bridge a VLAN into VNI or vice versa. Layer 3 Vxlan gateway is used for inter-subnet communication. Means we are sending the traffic between different subnet or different VNI. There are two architectural choices in terms of gateway placement: centralized Vxlan gateway or distributed Vxlan gateway. Let's start with centralized Vxlan gateway. As name says, in centralized Vxlan gateway deployment, layer 3 Vxlan gateway will be deployed at central location. Means inter-VNI or inter-subnet communication will be managed from central location. Also, security policies and access control can be managed from central location. Centralized Vxlan gateway deployment works pretty well for north-south traffic. Okay. Have you noticed something in this topology? Like inter-subnet communication between two hosts connected on same VTAP or on same leaf needs to be forwarded via layer 3 gateway. I mean, when we want to send the traffic from host 1 to host 2, then host 1 will send the traffic towards layer 3 gateway as host 2 is in different subnet. First hop VTAP will receive the traffic and bridge it towards layer 3 Vxlan gateway. This particular VTAP is acting as layer 2 Vxlan gateway. Layer 3 Vxlan gateway will perform the routing and forward the traffic towards destination. Overall, inter-subnet communication between two hosts connected on same VTAP or same leaf will happen via layer 3 gateway, which is not optimal. Correct? Time to start with distributed Vxlan gateway deployment. So distributed Vxlan gateway allows us to move layer 3 boundary close to end host. Means each VTAPs will act as layer 2 Vxlan gateway as well as layer 3 Vxlan gateway. All VTAPs or all leaf devices will be configured with same gateway IP address and MAC address. Let's take Same example where we want to send the traffic from host 1 to host 2. This time, first hop VTAP is acting as layer 2 VXLAN gateway as well as layer 3 VXLAN gateway. Means when VTAP receive the traffic, it will perform the routing and send the traffic to host 2. This resolves the problem which we faced in centralized VXLAN gateway deployment, right? Now, you may think which one is better, whether we should go with centralized VXLAN gateway deployment or do we need to go with distributed VXLAN gateway deployment. So overall, it depends on a customer application requirement or traffic patterns. Okay, now we will discuss symmetric and asymmetric IRB. Let's recall traditional inter-VLAN routing and then correlate inter-VLAN routing with inter-VNI routing. As we know, there are two ways to perform inter-VLAN routing. Router on a stick, where we have a router connected to layer 2 network. We configure multiple sub-interfaces depending on VLANs. So in this particular diagram, we have two VLANs, which means we are gonna create two sub-interfaces and going to associate these two sub-interfaces with particular VLAN. So this particular sub-interface is associated with VLAN 10, and then we have another sub-interface created which is associated with VLAN 20. So when we want to send the traffic from host 1 to host 2, then the router will perform the routing and send the traffic from VLAN 10 to VLAN 20 using these sub-interfaces. Correct? Second option for inter-VLAN routing is SVI, Switched Virtual Interface, where we have layer 3 switch with SVI configuration. SVI IP address is gonna act as default gateway for end host. Inter-VLAN routing will be performed by this switch. Configuration wise, we have layer 2 VLAN configured and SVI configured on layer 3 switch. This is closest match to asymmetric IRB. Main difference between asymmetric IRB and symmetric IRB is where we are gonna perform layer 2 and layer 3 lookup. Let's start with asymmetric IRB. Please pause the video and have a look on this topology. In asymmetric IRB, ingress VTAP will perform both layer 2 bridging lookup and layer 3 routing lookup. Egress VTAP will only perform layer 2 bridging lookup. Okay, let's understand this with example. Let's say we want to send the traffic from host 1 to host 4. Host 1 belongs to VLAN 20, which is associated with VNI 120. Host 4 belongs to VLAN 30, which is associated with VNI 130. So traffic will be bridged towards default gateway as destination is in different subnet. So this VTAP will perform routing, means traffic will be routed from VNI 120 to VNI 130. It seems like routing the traffic from one VLAN to another VLAN. Then this traffic will be sent via Vxlan fabric to remote VTAP. At remote VTAP, decapsulation will happen and traffic will be bridged towards destination. Means we are doing bridge, route, bridge. At ingress VTAP, we are performing layer 2 and layer 3 lookup. At egress VTAP, we are performing only layer 2 lookup. In asymmetric IRB, each and every VTAP needs to maintain MAC address table for all VNI, even though there is no local host. Okay, now let's start with symmetric IRB. In symmetric IRB, ingress and egress VTAP will perform both layer 2 bridging lookup and layer 3 routing lookup. Let's understand this with example. Let's say we want to send the traffic from host 1 to host 2. Host 1 is part of VLAN 20, which is associated with VNI 120. Host 2, which is part of VLAN 30, and VLAN 30 is associated with VNI 130. In this case, traffic will be bridged towards default gateway on ingress VTAP. Okay, then traffic will be routed towards destination. Okay, on egress VTAP, first traffic will be routed and then it will be bridged towards destination. Means we follow first we are bridging, then we are routing. On remote VTAP, first we are routing and then we are bridging towards destination. In symmetric IRB, we configure L3 VNI on all VTAPs. Also, L2 VNI will be configured only where local port exists. Make sense? At this point, we understood that symmetric and asymmetric IRB have same outcome. I mean, both is used for inter-subnet communication. Correct? Symmetric IRB is more scalable and widely deployed, as VTAP does not need to maintain unnecessary ARP and MAC. Also, there is no need to configure destination VLAN or VNI at source VTAP. Correct? Hope this session was useful. Thank you.